So we're looking at impulse and momentum, or impulse and change in momentum. A change in momentum, which is mass times the change in velocity, is equal to the impulse on an object. The impulse of an object is a force acting on an object over a certain period of time. Now, these are the units for all our variables. Mass is in kilograms, change in velocity, which is final velocity minus the initial velocity, is meters per second. Force is in newtons, time is in seconds. So you're given three variables here. The impulse, which acted upon the mass. So you have a 6 Newton force acting on 1.5 mass for 5 seconds. Find the impulse. Well, force is in newtons, so 6. Time is in seconds, that's 5. 6 times 5 is going to equal 30. And if it's just impulse by itself, the unit is force times time, Newton times seconds. Cool. What change in momentum is produced? Well, I don't have any numbers in letter B, so I'm not sure what to do. Looking right here, change in momentum is equal to the impulse. So the unit, or the number's the same, it's 30, but you're going to use the unit for momentum now. Kilograms times meters per second. There is no special unit for impulse. There is no special unit for momentum. So in this case, right, again, it says it right here. The impulse on an object is equal to the change in momentum.
Please report to the main gym foyer for your bus. Again, all swimmers, please report to your main gym foyer.
So change in momentum is equal to the impulse, so it's the same number. You're just going to replace the unit. Momentum unit, kilogram meters per second. If it's the impulse that they're looking for, Newton seconds. So it's the same number. Different unit. Cool. So you can set these two things equal to each other. The mass times the change in velocities, force times the time. And you may see sometimes the delta T, start time and finish time, but it's pretty much should be just force times time. So they want you to calculate the change in velocity. So let's see. kg is mass. We're going to put that unit, right, or that number directly under m. So I'm going to put the 1.5 directly under m. They want us to find the change in velocity, so your delta V, we're leaving that there. The force was 6 newtons, all right, force is in newtons. And T is the time, and that was 5 seconds. So to get delta V by itself, you divide both sides by 1.5. So in your calculator, guys, all you're doing is you're throwing in 6 times 5, and then dividing it by whatever the opposite, or whatever's on the other side of your equation. In this case, it's 1.5. So delta V is going to come out to be 20 meters per second. The next problem, force, all right, 8 newtons. I'm going to put 8 directly under F, bring down the equal sign. kg goes under M, that's 2. Velocity, meters per second, is under V. So we're looking for how many seconds, how much time. So to get T by itself, you're going to divide both sides by 8. 2 times 5 is 10. 10 divided by 8 comes out to be 1.25 seconds. All right, next one. You have velocity. Velocity is changed by 1.5 meters per second. The force is 3 newtons. We're going to set that equal. We're looking, I'm sorry, trying to do that too quick. 3 newtons goes under F for force. 4 seconds, that goes under T for time. They're asking us to find the mass of the object. So M is chilling there. Divide both sides by 1.5. And in this case, M should come out to be 8 kilograms. What force is necessary in order to change the velocity of a 2 kilogram object by 7 meters per second in 10 seconds? So M is mass, 2 kilograms is for mass. What force, velocity would be 7, so V is 7. They want to know what force is, so that's our question mark, so we're just going to leave that as F. And the time that they gave us is 0.10 seconds, so 0.1 seconds, divide both sides by 0.1. 14 divided by 0.1 is going to tell us that you're hitting here with a mass of 140 newtons. The next one, you have a 10 kilogram mass, kg, you're going to throw it under M. It's traveling with a certain velocity. It's impacted or is acted upon by a force of -5 newtons. So the -5, that could basically just be saying, hey, if the object is moving to the right, all right, a negative force would be the force going in the opposite direction. That's what would make the force negative. So if the velocity is going to the right, force opposite directions, that can tell you why we have a negative force. So a force going in the opposite direction of motion would cause it to kind of slow down. So we're going to change its momentum. All right, now a change in momentum, you're not necessarily changing the object's mass during the middle of the motion, but you can change the velocity. You can slow it down. We can decrease. So the force here, you have to make sure you put in the negative sign though, -5, and then the time is 4 seconds. So we're looking for delta V. Dividing both sides by 10, -20 divided by 10 will give us a -2 meters per second. And then this last one, 2 kg, that is going under M. Velocity is changed by -9. Bring down the equal sign. We're looking for F, and T is 3 seconds. Divide both sides by 3, and the force should wind up being 2 times -9 is -18, divided by 3, -6 newtons. The next one, they say, hey, you have one cart, all right, is moving at a certain mass at a certain velocity. Mass is 2 kilograms. Velocity is 30 meters per second to the north. 2 times 30 is 60 kilogram meters per second, and it's moving to the north. It is moving to the north. The next one, a 1.5 kilogram cart, put that under where the M would be, is moving at 40 meters per second going to the south. This is also 60 kilogram meters per second, but it's moving to the south. And it asks, are they the same? All right, and I'm pretty much going to say it's the same magnitude. All right, so the same number. In the opposite directions. In this one, golf ball, 0.1 kilograms, so 100 grams. All right, so if that is 0.1 for the mass, it's originally at rest and it gets up to 50, so the change in velocity would itself be 50 meters per second. We don't know how hard we hit it with, but we know that the golf ball and the golf club are contact only for 0.005 seconds. So to figure that out, you're going to divide both sides by 0.005, and you should kick out a value here of a force of 1,000 newtons. Number 9. For number 9, a billiard ball is shown that has a mass of 0.2 kilograms and is thrown against a steel plate and it rebounds as shown. Find the change in momentum of the body. So change in momentum is delta P. Since we're not changing the mass of the object, we are going to change the velocity. So delta V is simply the final velocity minus the initial velocity. So if it starts going to the steel plate and then ricocheting off, this guy would be your initial velocity. So you have an initial velocity of 20. The final velocity is the velocity that it comes off of with at 18 and the mass. So to do this, delta P would equal the mass of 0.2 times final velocity minus the initial velocity, which was a negative 20. And throw it into your calculator just as such. 0.2 times 18 minus a negative 20, and it kicks out a value here of 7.6 kilogram meters per second. That is how much, all right, change in momentum that we had. For number 10, you have mass and velocity. Mass, kg, goes under m. Velocity, v, goes under 4. Multiplying those out, you get a momentum of 12 kilogram meters per second. Now they're saying if a 5 Newton force acts to the right on the object for 1.8 seconds, what is the new momentum going to be? Well, to find the change in momentum first, you're going to multiply force times time. That's going to be the change, how much it changed. So right now, the object's moving at 12. Let's just say that, all right, it's a little kid on a tricycle, all right, and it's moving to the right. Your force, you're also going to now push on the object to the right. So you should make sense that this thing is going to wind up increasing its momentum, because if you push on it in that same direction, it should speed up. We just got to figure out by how much. Now I wrote in parentheses, find the change in momentum, which is this first, and then add it to the answer from part A, which is your 12. So how I'm going to show this is delta P is equal to force times time. The force was 5 newtons for 1.8 seconds, and this gives us 9 kilogram meters per second. That's how much we're going to change by. All right, and just so we're clear, for number 11, you're going to do this the exact same way. You're going to take the initial momentum, which is in part A, plus the change in momentum, which you just did here in part B, and that is going to equal the final momentum. So our initial momentum is 12. Our change in momentum was 9. So the final momentum for this problem, and the full answer, would be 21 kilogram meters per second. All right, so you had to first do just mass times velocity. All right, then you're going to take the impulse, which is force times time there, multiply those together, and so we're going to increase the change. All right, we're going to increase our momentum by 9. So if we were initially moving at this, we get a little boost from someone pushing, all right, or something pushing. Add those two together, and now you're moving at this final momentum there. So you guys are set for this. You please complete number 11.